Hello, this is Mr. Stansbury. I'm going to take you through the notes on congruent triangles. At the end of this, you should be able to say I can use the fact that congruent triangles have congruent corresponding parts, and I can determine unknown angle measures or side lengths in congruent triangles. Okay, so first thing here, we know that corresponding parts of congruent triangles are congruent. And we actually call that CPCTC. Corresponding parts of congruent triangles are congruent. Okay, and this is actually, this here is, the CPCTC is used a fair amount in proofs, which we're going to come up to later on. Okay, so first thing, identify what parts are corresponding by using the congruency statement. Okay, so if we have triangle ABC is congruent to triangle XYZ, we can figure out the congruent angles and the congruent sides. We actually talked about this a little bit in the 10.2 notes as well. So this means that angle A is congruent to angle X, angle B is congruent to angle Y, angle C is congruent to angle Z. Also, we know that segment AB is congruent to segment XY, segment BC is congruent to segment YZ, and segment AC is congruent to segment XZ. Okay, to show that a little bit here, let's say we've got two congruent triangles here. Okay, so what we're going to do is we're going to name the corresponding parts. So here, this is, it looks like it's close to a 90-degree angle. These two angles are the same, right? So they've got these here. Okay, we also can tell that these two angles here are going to be the same. Since I got to back up here a little bit. They're going to tell us here that these two triangles are congruent, so we're going to figure out we're going to just kind of show what which piece is congruent to which on these triangles here. Okay, so we know that this angle here, this B, is congruent to angle Y. Okay, and we're basically doing the same thing up here. And then we also have that this C is congruent to that Z here. So that's 3, and that's 3, okay? Now, that also means that we know that, again, this AB is congruent to XY. So this here is congruent to this. We know that BC is congruent to YZ. So BC, this one here, is congruent to YZ, this one here. And then by default, the last one, AC, is congruent to XZ. Okay? Okay. All right, let's take a look at an example here. This is 1, 2, and 3 from our book here. Greg wonders, if I know that two triangles are congruent and I know that the side lengths and the angle measures in one triangle, if I know that side lengths and angle measures in one triangle, do I have to measure all the sides and angles in the other triangle? Greg begins by examining two triangles from a truss. According to the manufacturer, the two triangles here are congruent. Because the two triangles are congruent, can one triangle be mapped onto the other? If yes, what are the criteria for mapping? So this basically here is just a rigid transformation, meaning it's not going to change how big or small it is. And really, if you look at it, it's just going to reflect across this line here, right? So A is going to map onto D, B is going to map onto E, and C is going to map onto F. Okay, so basically, the book is telling us that each triangle can be mapped onto the other triangle by a sequence of rigid motions. That rigid motion, really, the easiest way is just a reflection, right? So we can do a reflection to map one onto the other. Okay, for 2 here, suppose you use a sequence of rigid motions to map triangle ABC onto triangle DEF. Find the image of each of the following under this sequence of transformations. So AB is going to reflect over this line to go to DE. Okay, so AD is going to reflect over, it's going to map onto DE if we're doing the reflection. There's other ways to do it too, but this is probably the easiest way. Okay, angle A here is going to reflect over the line to get to angle D. Okay. BC reflects over this line to get to EF. Hopefully you can see this. Hopefully this makes okay sense here. And then angle B reflects over this line to turn into angle E. And then AC reflects over this line to get DF. And then angle C reflects over this line to get angle F. Okay? So 3 says make use of the structure. What is the relationship between AB and DE? And what's the relationship for angle between angle B and angle E? How do we know? Well, each of those are congruent to each other, right? So we know that AB is congruent to DE. And then we also know that angle B is congruent to angle E. And the reason we know that is because we reflected this across this line, and it was a rigid transformation, meaning that, again, that it didn't shrink or it didn't get bigger. Okay, let's do this. One last thing here. We're going to do an example, but before that, let's take a quick little video break, shall we?
Come on, Chewie! Come on, Chewie!
AJ, fist bump.
Nope. Okay. This example here. So we're going to mark the triangles to show this the congruent parts of the congruent triangles that are congruent. And then we're going to find all the side lengths if they have these different things here. So let's mark up this triangle. So we know angle A, oops, let's see. A is congruent to D. And then we've got B is congruent to E. And then we also know that F and C are congruent as well. All right, and then as far as the side lengths go, we know that this side is congruent to that side, this side is congruent to that side, and then this bottom side is congruent to this bottom side here. Okay, now it's saying if measure of angle A, find all side lengths and all angle measures if we're given all this information here. So I'm going to do this. Let's write down all the things that we need to find. Okay, so here's all the things that we need from both triangles. Some of them they already gave to us. So maybe a good idea first is to maybe write our little congruency statement here. So we know that triangle ABC is going to be congruent to, so A is congruent to D, B is congruent to E. Oops, I forgot the triangle symbol again. All right. D, E, and then C maps to F. Okay. So measure of angle A is 37. Measure of angle E is 92. AC is 7. So I'm just gonna fill in all the blanks here. Okay, I filled in all the pieces. Now we're gonna find all the blanks. So we know that A and D are the same. So A and D. So this is 37 degrees as well. Okay, and then E is the same as B. So that's going to also be 92 degrees. And then to figure out this last angle, all three angles of triangle always have to add up to 180. So if we do 92 and 37, that's going to give us 129 degrees. Oops. 129 degrees. So if we take 180 minus 129, that's going to give us 51 degrees. So this is going to be 51, and this is going to be 51. Okay, and then this here, AC, first and the last, is going to be the same as DF. So this DF is 7 inches. And then EF, these last two, that's going to be the same as BC. So EF, that's going to be 6 inches. And then DE is the same as AB, which is 4 inches. So now we have filled in, we've figured out every angle and every side of that just from this information there. Okay? That's all there is for congruent triangles. If you have any further questions, please feel free to ask in class. Thanks.